Hey Vaquero kids, so today we are going to learn more about the properties of matter. Okay, so yesterday we talked about the states of matter, solid, liquid, and gas. And I saw some incredible work from you guys, so I'm really glad that you guys are enjoying these lessons. So more properties of matter. Some properties of matter such as mass, weight, volume, and density are measurable. Scientists use tools to measure these properties. For example, a balance can be used to measure mass, and a scale can be used to measure weight. Mass and weight. Sometimes people confuse mass and weight. These two properties of matter are different. An object's mass is the amount of matter it takes that makes it up. The mass of an object does not depend on the object's shape. A piece of paper has the same mass whether it is flat on a desk, folded in half, or shaped into a paper airplane. So it doesn't matter how the paper is folded, it is still has the same amount of mass. It's how much space it takes up. It's always the same, no matter if it's folded, no matter if you make it into an origami swan. Okay, so weight is a measure of the force or pull of gravity between an object and Earth. Weight can change if the object is moved to a place where the pull of gravity is different than on Earth. The mass of an object stays the same even if it's put on the moon. So let me give you an example here. So if I went to the moon, I would have the same amount of mass as I do here on Earth. But if I went to the moon, I would weigh 1/6 of what I weigh here on Earth. 1/6. So my fourth graders have been doing base 10. And so when we say 1/10, that means divided by 10. So gravity on the moon is less than the gravity on Earth. The pull of gravity on the moon is 1/6 of that on Earth. So that means that whatever you weigh on Earth, you would divide it by 6 to determine how much you weigh on the moon. Suppose the astronaut shown below has a weight on Earth of 180 pounds. On the moon, the astronaut's weight would be about 30 pounds. The astronaut's mass on Earth and on the moon stay the same. So mass is the amount of space he takes up. That stays the same no matter where he goes. But the weight changes because of the pull of gravity. So on Earth, that astronaut weighs 180 pounds, but on the moon, it's only 1/6. So he weighs about 30 pounds on the moon. Okay, let me go to the bottom of this page, volume. The amount of space that matter takes up is called volume. Solids, liquids, and gas have volume. As you blow up a balloon, its volume increases. So the air that you blow into the balloon takes up space, and the volume increases. Density. The property of matter that compares an object's mass to its volume is called density. Different objects may have a different mass but the same volume. A cube of copper has more mass than a cube of balsa wood. The cube of balsa wood has less density than the water, so it floats. The cube of copper has greater density than water, so it sinks. Okay, we're going to go over that a little bit more a little bit later in this lesson. So for today, you're going to have 2 questions, and I want you to write incomplete sentences. Have to write incomplete sentences to get credit. Your question is going to be to compare and contrast. How are mass and weight alike? And how are they different? So you have to write a full sentence. So you're going to have to say, mass and weight are alike because of so, so, and so, and so. And then you have to say mass and weight are different because of so, and so, and so. Okay, your next question is going to be, how much would you weigh on the moon? Okay, so guys, please make sure that you message me in the comments if you don't understand the assignment, and I will get back to you as soon as possible. Thank you.